Welcome to a lesson with Dr. Powell. Let's take a look at how we can use Green's theorem to calculate the line integral along this path in the xy plane with this particular vector field. So this vector field integrated along this line, or this curve, this enclosed loop that we have right here made up of these segmented pieces here in the xy plane. So let's use Green's theorem to help. All right. So first of all, let's write down this vector field as a differential one form. So x minus y squared dx plus x squared minus y dy. All right. Now we're going to do this exterior derivative type idea where we take d of this and d of that. Now, how can we do this? Now, essentially, what we could do is we could just take the, just think of this as dx minus 2y dy, and we're wedging with dx. Essentially, you could just do that, just take the d of that part and of that part as follows. You could also think of this as a function in x and y, call it maybe like f, say, and then literally think like fx, fy. So df literally is just this dotted with dx and dy, kind of, these are the runs, that's the rise. But and you notice you do get the same thing. The partial respect to x is just 1, the partial respect to y is just negative 2y. Well, however you look at it, this might be faster in this particular case though. And then we have plus, we do the same thing over here, 2x dx minus dy, and we're wedging with dy. Okay, now with this wedge, we can just eliminate anything that's the same with dx here, or here, the same thing with dy, because it's just 0. So we essentially just get this, where we notice this is out of order, the dy dx, so we make it, so we change the sign right here. So we end up getting 2y from here. You can factor out the dx dy and eliminate the wedge because now we're ready to integrate. And then over here we'd have just 2x. Okay, so plus 2x. So we're just basically integrating this as a double integral over that region. Okay, great. So we kind of set this up. Now we could have done that more quickly, but I just took some time to explain the ins and outs. In fact, if we wanted to, we could just ignore anything that would come from a dy, from a dx here, and just thought of that, thought of the negative 2y here. Maybe more quickly, we could have just noticed just the 2x will be important here. And so we could have actually just looked at it and noticed, especially here, we're going to reverse the sign. So we could think positive 2y plus 2x just very quickly. That if we were adept at thinking through this. So we get 2y plus 2x right here, and we're integrating that over this particular region. So let's look at that integration now. Okay. So in integrating this, notice that, let's see, let's take maybe as x goes from 0 up until 2, it looks like, where it crosses the x-axis, 0 to 2. Y will be going from, so if we're given x, y will go from 0 up to this value right here, 0 to 4 minus 2x, and then we simply have 2y plus 2x. That's a dy. We could factor out the 2 if we wanted to. And so then we just have y plus x in there, with a 2 factored out here. Okay, so just y plus x. All right, so with respect to dy, this would just be y squared over 2 plus xy, going from 0 to 4 minus 2x. Okay, so at 4 minus 2x, it becomes 4 minus 2x quantity squared over 2, and then plus, and here you have a x times 4 minus 2x. Okay. So we get this. This is what the inner portion will be. And we're going to be integrating this now with respect to x. So let's just multiply it out. So, okay, in doing so, for one thing, I'm going to, just to make this slightly simpler here, I'm going to factor a 2 out of each factor. Here, there's 2 of them, so it'd be like factoring 4 out of the whole thing. 4 over 2 would be 2. So basically, I'll just say 2, and then I'll think of this as being 2 minus x quantity squared. It'd be 4 minus 4x plus x squared, and then plus 4x minus 2x squared right there. Okay. Notice that that'll cancel with that after we distribute. And so then we're left with, looks like 8 minus, see, yeah, so 8 minus 4x even. So we end up getting, since we get negative 8x plus 4x, will give you back to negative 4x here. Okay, so this is what we're integrating. And we have an extra 2 sitting out here. Just keep that in mind from up there. And we're going from 0 to 2 dx. Then we take the antiderivative of this. I mean, further, we could factor out a 4, I guess. So really have 8 multiplied by 2 minus x. Okay, and we're going from 0 to 2. Which actually is equivalent to, if we really wanted to, we could do a quick u substitution, make that a u. U would be going from 2 to 0 now, but we have a negative du, but we can switch that negative to just have 0 to 2, and that would be fine. 8 du, and we really can just replace it that way. U squared over 2 then, from 0 to 2 would yield 2, so 2 times 8 would be 16. So we should get this line integral then. We just tried using Green's theorem to compute the line integral by converting to a double integral, and then with a little change of the vector fields using this, this trick here of Green's theorem. Thanks for watching.